Hello, my name is Klosek. I'm Software Quality Director in Schneider Electric, a worldwide operating company. I want to show you today our activities on preventive quality activities plus mid to long-term securing quality of software of any kind. Is it cloud software, embedded software, or desktop software? For us, it's just code running on different platforms. We are using a company-wide quality model based on ISO 25010, which is implemented in Squore. I guess that's all for introduction. I'm happy to be here with you in such strange times, and so let's just make it happen. So let's have a look to qualimetry, our preventive quality actions from methodology to implementation, where you also can see Squore, which we are using. Having a short look on Schneider Electric. So being a global player, we have the mission to power and digitize the economy. That's part of our mission statement. We are, as global player, working around the globe and have 135,000 employees, just one of them. And we are investing 5% of our revenues to R&D. You see that we are really looking into or working on a lot of segments: gas and oil, mining, mineral, just and automotive companies, just to talk about some of them. But it's not the task now to talk about what we are doing or who we are, but more about talking about qualimetry, the preventive quality activities for software. Well, let's start with a voice from our CEO, who for sure pushes quality messages down to the teams. Talking about product quality starts at design, and we need to improve. 40% of our quality issues are based in design, and we should do less correction but more prevention. Maybe it sounds familiar to you, but it's very good to have this spoken towards the teams. Something out of this or even other areas, it's about what you can't measure, you cannot improve. So that means we need to see where we are and what can be improved. So our qualimetry approach has mainly two pillars. So the first one, which is to prevent, find and fix bugs as early as possible. It's clear. If you look to the right curve, maybe you know that the later you find the bug, the more costly it will be. If you find it during coding, so it's pretty cheap. It's a matter of minutes, hours, and it's no longer days. What you for sure can spend when you find a bug short before releasing something or even at your customers. So here we are using static code analysis to find bugs. Just one tool to mention, it's Clockwork, which we have in place. We also have SonarQube. We played with Caverity, and so we know a lot about such tools. And the second pillar is about measuring and improving the quality of software. It's a very high statement, that's clear. So we are using internal software quality model, which is based on the ISO 25010, which is the de facto standard of what is quality in software. It's a successor of the 9126. Just talk a little bit about numbers. And we have a dashboard for software quality, which shows up, very on high level, what is the distribution of quality. And we just don't talk just about bugs and are bugs fixed or something like that. We can see very early the software quality. That means early during coding or after the first sprints, for example, you can have a picture of what's going on. And we are not waiting until everything is implemented, and we see now the bug trend. We just check about feature implementation and if this is now all in. It's clear we look inside, we look very early inside, and software turns from black box to white box. That means it's no longer as a tunnel effect where R&D teams just start coding and after some months or even longer, years, they just appear with the ready software and we will recognize, oh, maybe something is missing. And all of these things with the ISO 25010 implementation, the dashboard you just have shown is provided by Squore for us. Internally, we have a quality maturity model, which shows up from red zone, you do nothing for quality, to green zone, you are the best, you do everything. Inside there is the pillar measure, which is implemented by Squore, and static code analysis as well. So just to focus on the main part of this model, that's the measure part about ISO 25010. The indicators you will see a little bit later. The rating is that this kind of measurement and displaying in dashboard is very high accepted by managers, architects, and later also by developers. First, they are skeptical because their software gets measured. They don't know, are we now software police or not? So we have to be very careful. No, that's not our intention. It's about showing do we have some weaknesses in design or not? Yeah, that is just again to highlight what it is. That's just this pillar of the quality maturity model we have created. And Squore itself is kind of giving an eagle view to the software quality. It's not looking to the bugs or something like that, but it gives you a very high level quality picture. It supports you to get some guidance for reviews, so, and quality improvement. So imagine you have 1 million lines of code, 100,000 lines of code in front of you. You don't know where should we invest in improvements for quality activities. So here we can open the box and just have the view on quality distribution and to recognize maybe where should we review some code, some algorithms with the teams. It's not just about make it better, but also to identify where should we discuss and about what should we discuss. We are using our Squore or this model implemented in Squore for also acceptance criteria for outsourcing and getting code back when we want to check, okay, what's the real quality of the code and not just about are the features working. So this is very important that we can see now much better the deliverables and their quality. Inside the measuring engine and the model, we have defined or we are using so-called software code quality indicators. Very well known, hopefully, is technical debt, which reduces all quality deviations into one number, which makes it easy to just see where we are. But it's not the number what makes it interesting, it is a trend. That means that teams are working on quality by reducing technical debt, and we monitor the trend and it should go down. And we can also see if it goes up or something is just flat, that maybe something is wrong, maybe teams have no time and they can't work on quality. Inside there's maintainability, performance, efficiency, and reliability in this model. Not everything from the ISO 25010 model, which is just here, can be measured because something is about feedback from testing, about usability, and so on. But those things which are measurable, they are implemented and we are using them. Very important is that for a lot of these areas which are measured, we can have trends, we can compare builds, versions which are measured. So that means, are we getting better from one iteration to the other? Not just about the technical depth, but also about just maintainability, is it getting better? You can focus your work on the one or other criteria and see if the teams are going in the right way. And what's very important, you can drill down to the source code. That means you have a very high level display of, well, maintainability is not good. You can go into your module, in your file, you see what files are not good or should be worked on. In the file, you see the functions, and in the function, you can see the lines and the deviations, because developers, they for sure don't care just about the dashboard view. They want to know what is it, because they need clearly to understand, and that's a clear advantage here, that we can really drill down to the source code and see the quality flaws. So in general, when we are going to report quality, this is something the teams have implemented in Squore, what the quality people are using. We are looking to quality trends. These are kind of priority one findings, so they need to be 0 on cell. So, or cybersecurity findings. It's just okay. We monitor from the first iteration the trend of such quality goals. We monitor the technical depth. So everything is nice, it's going down. Maybe here they have some code integrated from another team or from a supplier. So it's normal that you have an increase on technical depth. We can have the energy scale, or we have like on your fridge, it's about A to E, say, okay, what is it? And some quality indicators in Kvyat or distribution diagrams. All of them makes a good view on the quality of a software. None of them should be used as a singleton. So that means it's too easy to look to the quality, to the energy scale. You have to look to all of them and build your picture, because sometimes people are working on the right way with the right spirit, but they need to work more to maybe come from D level to C level. And so, but technical depth trend is good. So the work is well ongoing. On our implementation inside Schneider Electric, so we have meanwhile on this qualimetry, it's a big program. We have the process description, the methodology, the tools, and we have training. We deploy it globally to everybody working on software, firmware. I told you that's just software. So the organization is decentralized, so we dispatch it over the globe. As you've seen, we are a big player, so we can't just run it just on one place. And at the end, it's the developers doing the work. There's no organization doing the work for them. It's always developer working with Squore or Clockwork or something like that. We can certify our internal development efforts or the project if they are on target. And to make this happen, it's clear we need full support from management, what is established. I want to show you, besides that, a success story by a team using Squore. So there was a team, to understand that they had, here is the number one, maybe this is better like that. The number one, there were several modules in 2001, it's a longer time ago, but it just doesn't mean a lot, where they measured the technical depth, and they were really, here was the target, far beyond the target. So, and they started to work on identifying the quality flaws, the technical depth, and they were working then since 2010 using Squore to see very easily what is the quality, what are the deviations, where should we focus our work on. And they finally reduced the complexity of the firmware. At this point, it was a firmware project by a factor of 3. So factor of 3 is really great. So it doesn't mean it's our reference when we talk about making something happen with Squore. Of course, meaning less complex means less tests, less quality flaws, we have some clear advantage here to be able to reduce and to show that it's possible to reduce the technical debt. As well, the team has now no longer several reports and dashboards from several tools which has been used before, like PCLint or whatever. So we are using the quality model and have just one tool, one project in the tool, one dashboard with several elements, it's clear, but very consistent together. And so they can use it really as an aggregator and decision-making tool. So that's, we could continue with the success stories, but I would like to show you the environment. So how do we integrate that towards our teams? So on the left part, you see the developer with his machine. I don't know if it's really the right one. They're using, in terms of this, with Qualimetry, Clockwork, and Squore. So we have continuous integration in the middle here, where we run everything integrated and automatic. And the reports are brought from Clockwork to the Squore servers as well. So we aggregate data from static code analysis to the Squore result about cybersecurity areas. And the Squore server at night pulls the source code from the SCM systems and is creating the results for the dashboard, where the teams can look to them in the morning or whenever they like. It's not really that we have to do it each day. So we have to do it several times during an iteration, but it's not mandatory to do it each day. So that means it's all integrated. Everybody has access to the tool. It has continuous integration as the core part. We will continue forward to continuous delivery or DevOps very soon. So with that, it is mandatory that integration of tools can be done in the CI environment, and we have results all automatically. It's not the fixing, it's just the result. So that's clear. And yes, finally, it's clear we are all looking for the unbeatable tool for cybersecurity and Qualimetry, which is not existing. So I always say it is software measuring software. It has strengths. It has also weaknesses. We talk about false positives where, well, there is an indication that there is a bug, but there is no bug. So yes, okay, the tool does not understand. So we can flag it and say, okay, next time, please don't report this bug again. Well, that's it for Qualimetry and preventive quality actions using ISO 25010 and having implemented that in Squore. So I would like to answer your questions. Thank you.